AP Calculus BC, Unit 7, Day 11, office hours. It's the pre-test for the test. So this covers quite a bit of stuff. So this pretty much covers what we need for both parts. So I think I'll probably break it up just halfway into it and do a separate video after it. Give myself a break. So first one, approximating definite intervals with either Riemann sums or trapezoids. So RE is right end. I'll draw a picture 3 to 35. All right, 3 equal subintervals. 3 to 35. The gap is 33. So divided by, if you did 35 minus 3 divided by 3, or does that make sense? No, 3 to 35. Yeah, I guess so. 32. I guess, okay, a little typo. Let's make this 15. I think that's what I intended, and it would work better that way. And also 35 isn't even on this graph, so we're going to go 15. So 15 minus 3 is 12, divided by 3 is 4. So it's 3 to 15. 35 will not work because those values aren't even given. So each gap is 4. Those are going to be the bases of your rectangles, and 7, 11. Look up these values in the table. So 3, 6, 7, 3, 11, 13, and 15, 4, just relatively. Now we're doing right end, so we're using the right edge as our height. Right edge, which means we're not going to use this one this time. We need to show your setup. So 3 to 15 of f of x dx is approximately base times height, 4 times 3. Base times height, 4 times 13. Base times height, 4 times 4. So it's going to be 12 plus 52 plus 16 is 28 is 80. That's your approximate answer. It's approximately 80. Okay, midpoint, 3. So similar picture. 3, 7, 11, 15. Bases are 4, but we got to find the heights at the midpoint. So the midpoint here would be 5, 9, 13. So 5 is a height of 2, 9 is a height of 6, and 13 is a height of 8. And those are going to be the heights of our rectangles. So we're going to show our work. We're going to say, all right, 3 to 15 of f of x dx is approximately base times height, 4 times 2. Base times height, 4 times 6. Base times height, 4 times 8. So that's going to be 8 plus 24 plus 32. 40 is 64. 64. Did I make a mistake? No, 64. I think I have a mistake in my original solutions. Okay. Left in 6 subintervals. So, we could use these 5, 7, 9, 11, 13, 15. So we're going to have 6 at 5, we're at 2, 7, we're at 3, 9, we're at 6, 11, we're at 13, 13, we're at 8, 15, we're at 4. So left end, we're using the left sides. We're not going to use this last one. The bases are all 2. So 3 to 15, f of x dx is approximately base times height, 2 times 6, 2 times 2, 2 times 3, 2 times 6. Let's see. So we get 6, 2, 3, 6. 2 times 13. And 2 times 8. So that's going to be 12 plus 4 plus 6 plus 12 plus 26 plus 16. So that is 10, 22, 34, 40, 60, 76. So we get about 76. Okay, trapezoid. We could use our drawing from the first one, 3, 7, 11, 15, 6, 3, 13, 4. And trapezoids connect both sides. These are actually going to be the height of the trapezoids. And the area of a trapezoid is really just base times height, because you can create a rectangle on them. The base, there's two bases, so it's the average of the bases b1, b plus b2 divided by 2 times the height. It's that. So we're going to get 3 to 15 of f of x dx is approximately average of the bases 6 plus 3 over 2 times the height. Average of the bases 3 plus 13 over 2 times the height. Average of the bases 13 plus 4 over 2 times the height. So we're going to get 2 times 9 is 18. 2 times 16 is 32. 2 times 17 is 34. 40, 50, 84 is our final answer. So you should be able to do some of those. No calculator. And then you should also be able to describe if it's over under estimate based off of whether it's increasing, decreasing. So this is decreasing concave up. So I would just draw decreasing concave up one slice. It says which of these give you an overestimate? Well, left in gives you an overestimate. Right in gives you an underestimate. Trapezoid gives you an overestimate. Okay, we want the ones that give you an overestimate. So trapezoid gives you an overestimate. Midpoint gives you an underestimate. So it's going to be left in and trapezoid. But picture goes a long way. All right. Area. Now, so both of these problems are in the no calc, part 2 of the test. Area problems are going to be on part 1, so you're going to have access to a calculator. So find the area of region R. So if you can do vertical slices, you do y top minus y bottom. You have to break it up. You find the intersection of those two graphs. And even though you have a calculator, it might actually be quicker just to do it by hand. This is the same thing as y equals 2 minus x. Move everything one side. And factor it, x plus 2, x minus 1, x equals negative 2, and positive 1. So this is clearly positive 1x. You plug 1 into both of them, it should confirm that they both give you 1. This x-intercept of this line would be when y equals 0, x equals 2. So this is 2, 0. This is 0, 0. So it's good to get all those points figured out. And so then for part A, we could do the area equals, we could do 0 to 1 of x squared dx, and then 1 to 2 of 2 minus x dx. We could do it by hand, or you could do it by calculator, whatever. X cubed over 3, 0 to 1, 2x minus x squared over 2, 1 to 2. It's going to be 1/3 minus 0. It's going to be 4 minus 2 minus 2 minus 1/2. So We get 2 minus 2. It's going to be plus 1/2. So we have positive 1/2 and a positive 1/3. So least common denominator 6. So we have 2 over 6 plus 3 over 6 is 5 over 6 is the exact answer. Or you could do it by calculator. You could do it with a horizontal slice instead. You wouldn't have to break it up into 2 integrals, which is one nice side effect. And really, in part B, we're going to look for y equals k, so we're going to have to set up with the horizontal slice for part B anyway, so you might see that and decide to do it with part, do that on part A also. So it's going to be x right. In terms of y, it'd be 2 minus y minus x left is going to be the positive square root of y. And we're going to go in the y direction 0 to 1. So that's how you would do it. It'd be 2y minus y squared over 2 minus y to the 3/2 divided by the new exponent. 0 to 1. So it's going to be 2 minus 1/2 minus 2/3. You plug 0 and you get 0 minus 0 minus 0. These common denominator is 6. So you get 12 minus 3 minus 4 is 5, 6. Same answer. So you got to find the area somehow in part A. Part B, we want to actually use a line y equals k, and it's going to divide it into 2 equal regions. So half is above, half is below. So we have to do horizontal slicing here. We have to do 2 minus y minus the square root of y like I just set up. And then I'm going to go 0 to k equals half of the area we just found. You could do k to 1 instead, but I think using 0 instead of 1 is going to make the calculations a little easier. You have to, even though you could have done these on your calculator, you didn't have to do the integration by hand. You could set it, you got to set it up. This part, you have to integrate by hand. And then you plug k in, 2k minus 1/2, k squared minus 2/3, k 3/2 equals 5/12. Plug 0 and it's all 0. Then I would solve this on my graphing calculator. So I'd move everything to one side. You might even consider getting rid of the fractions to just make it easier to type everything in. So that would give you 24k minus 6k squared minus 8k to the 3/2 minus 5 equals 0. You don't have to do that, but you can make it help out a little bit. So then we're going to use our calculator to solve this. And the way we're going to do is we're going to graph this equation equals 0 and find its x-intercepts. 24x minus 6x squared minus 8x to the 1.5, or you do 3/2, you got to put in parentheses, minus 5. Window is going to be 0 to 1. We're just, the x's are the values we're looking here, but they're going to be a y value, so it's only 0 to 1. That's all that's possible. And then just leave y min and y max at -1 and 1. And there's the answer. So second calc, 0. This is from 0 to 1, so I'm going to say 0 to 0.5, guess 0.3. We get 0.27551661. Okay, so we're just gonna write 3 decimal markers, 0.275 or 0.276. Okay. C says find the average value of the region R's function value. So those are like the y value. So if we're trying to find the average value, f average, what we do is we integrate the function from 0 to 2 and then divide by the base, right? I would memorize that form. Remember, it's the curve, the area of the curve, smooth out. Now it's a rectangle, divide by the base of the rectangle, gives the height of the rectangle. Now, this area, we already found it. Don't redo it. We already did it. It's 5 over 6. So we get 5/12 for the f average. Okay. All right. We have some more area, properties of definite integrals. So this one here, we're trying to find 12 to 10. We have 10 to 1 and 1 to 2. So if the top of one matches the bottom of the other, if you add these together, you're going to get 10 to 12. And so you would just add these values together, and it's going to be, it would be 12. Now here's the problem. What we want is upside down from what we had. So it's going to be the opposite sign. It's going to be negative 12. That's it. Okay, that's it. That's number 4. Number 5, find the area of this upside down problem, this line. So let's sketch it. Even though we have a graphing calculator, sketch is going to be very helpful for setting up. So it's an upside down parabola that's been shifted up to 1, 2. So upside down parabola. And then y equals x is that line. It looks like they intersect at nice points. So it looks like -2, -2. You could use graphing calculator to confirm this, 1, 1. We're trying to find the area in between them. So we could do vertical slicing, which I think is by far the best choice this time, because if you did horizontal slicing, you have to break it up into 2 separate intervals, which would be more work. So it'd be y top, which is the parabola, negative x squared plus 2 minus y bottom, which is a line, x dx from -2 to 1. Now, you could potentially use your calculator if it's on that portion of the graph, or we could do it by hand. One-third plus 2 minus 1/2. 8/3 minus 4 minus 2. Distribute the subtraction. So we have what? -9/3 plus 6 plus another 2 minus 1/2. So this is going to be -3. And let's see, that's 5. 5 minus 1/2 is 4.5 or 9/2. So there you go. If you did horizontal slicing, I guess I'll just show you, you would have to stop it right here. You'd have to do this part and this part. And so horizontal slicing, you would do x right minus x left. So we're going to have to do -2 to 1 first, -2 to 1. X right is on this line. That would be y in terms of y. X left, you have to solve this for x. So it's going to be x squared equals 2 minus y, square root of both sides, plus or minus. It's actually the -1 because this is the left side of the parabola. So it's negative square root of 2 minus y dy. And then you would do 1 to 2 in the y direction. And it would be x right minus x left. They're both sides of the parabola. The right side is the positive square root of 2 minus y. The left side is the negative square root of 2 minus y. So that's the setup. I don't know if I really want to keep going, but that's cleaned up a little bit. Antiderivative be y squared over 2 plus, this is going to be 2 minus 1/2 to the 3/2 divided by the new exponent. But chain rule says the extra negatives can come out that we don't want. So we got to fix it. And then the antiderivative of this one is going to be 2 minus y to 3 halves divided by the new exponent. But again, a negative pops out that we don't want. So we got to fix it. Chain rule. U substitution would take care of it too, but it'd be a lot of extra steps at work. So this is going to be what, 1/2. Plug 1 in here. It's going to be 1. So minus 2/3. And then we plug -2 in. That's going to be 2. -2 here is going to be 4. Square root of 4 is 2. Cubed is 8. 16 thirds. Here, if you plug 2 in, you get 0. Minus negative, if you plug in 1, you get 2/3. So there, that's positive 2/3, negative 2/3. Those end up canceling each other out. Distribute. So all that is, oh, actually, this is supposed to get a 2, so they don't cancel each other out. So what we have is we have negative 2/3 plus 16 thirds, so that's 14 thirds plus another 4 that is 18 thirds from all the thirds. We still have a half, and we have a -2. Least common denominator would be 6. Actually, this is going to be 6, so least common. I don't even want to bother doing that. So we're going to get 4 plus a half is 4.5 is 9 halves. Same answer, way more work. So choose wisely. Okay, number 6, volume by cross section. So I think volume by cross section problems will be on part 1. So graphing calculator will be allowed, but you guys should set up. So you're going to draw a picture. Parabola. Sideways parabola. Top. So it's a region enclosed by them. So I think it's this region right here. And then find the volume of solid whose base is this region. Cross sections are perpendicular to the x-axis. So they're going to be vertical and they are half circles. Okay, so this is volume by cross section. We need to find the intersections. I believe this is 0, 0. Both those are 0. If you set these equal to each other, x squared equals the square root of x, and you solve it, you get x to the 4th equals x. You move everything one side. You factor it. And you solve, you get 0, and you get 1. So this is 1, 1. So the volume by cross section is going to have some common area slices in terms of x, and this time they are half circles, and that is 1/2 pi r squared dx. So our volume is going to be pi over 2. The limits are in the x direction, 0 to 1. We cannot do this with horizontal slices. It would go against what they described. So the radius, this is the diameter. The diameter is y top minus y bottom. The radius would be half of that. So y top is y going to the top is square root of x. Y bottom is x squared divided by 2 squared dx. So this would be good enough for your setup. And like I said, I mean, you could do this on a calculator. I have the work on my solutions online, but I don't know. This is going to be on the calculator part, so you might as well get some practice with your calculator. Math 9, need parentheses, square root of x minus x squared, close parentheses, divided by 2, close parentheses around the whole fraction, square it, comma x, comma 0, comma 1, and we get 0.050. If you want to see the work by hand, you can look at my solutions online. Number 7, redo this, but the squares are square, cross sections are squares topped with equilateral triangles. I'm going to redraw this real quick, focusing on the area of the graph that we're concerned with. And I believe they're still vertical, but they're going to be squares topped with equilateral triangles. Okay, so volume is some area in terms of x dx. It's going to be squares plus equilateral triangles. So it's going to be side squared plus root 3 over 4 side squared if you memorize the formula for equilateral triangles. Otherwise, you can refigure it out from 60, 60, 60 triangle, which you should be able to do. These are the sides of the triangles and the squares. It's y top minus y bottom. So I personally would like to clean this up, and they both have s squared, so I'm going to factor out the s squared, but leave it in here and put the 1 plus root 3 over 4 out in front because those are the constants. We're integrating in the x direction 0 to 1. The sides are y top is x squared, or is the square root of x. Y bottom is x squared dx. So that's your setup. And then you could plug it into your calculator. You could try and do it by hand just to get some extra practice, but this is more of a kind of problem that will be on the calculator portion. So I would definitely take advantage of my calculator. Math 9, parentheses, square root of x, close parentheses on the square root of x, minus x squared, close squared, comma x, comma 0, comma 1. And we get the answer, 0.184, round truncated through decimal accuracy. Same either way. Solve the revolution. Will be on part 2, no calculator. I'll probably just be asking you to set them up. So we're just going to, and that's what the directions here say. You say set it up. We're going to set it up, set up the integrals, find, okay. Let's do it both ways. I'm going to be requiring you to do it both ways. So this is on part 2 of the test, no calc. The previous page, if you want to add these notes, these were both probably part 1 calc, part 1 calc. So this is going to be part 2, no calc. So I'm just going to be asking you to do the steps, but I'm going to ask you to do it with disc washers and also shells. So now we're doing all these problems. We're using the same original region. So, but we're going to revolve it different ways and slice it different ways. So you're probably going to want to redraw it. There's not a whole lot of room here. You'll have a lot more room on the test. So let's just get a good drawing to start with, and then we can make some sketches for each of these. So y equals x squared, y equals 2 plus x. There's a slope of 1, so it's kind of something like that. It says x has to be greater than 0, so it's just going to be this region here. We do need the intersections, corners of all these, so those corners are obvious. So these we're going to set equal x squared equals x plus 2. Move everything one side, x squared minus x minus 2 equals 0. We're going to factor it, x minus 2, x plus 1. You're going to get x equals 2 and negative 1. This is negative 1 over here. This is 2. If you plug it into both, you get 4, which is a good check. So that's the region we're dealing with. So on number 8, we're going to revolve it around the x-axis. So I'm going to draw a new, just small picture right here. And we revolve around the x-axis. So it's going to look like that. So with vertical slicing, we're going to get disc washers, right? So the volume is going to be pi big R squared dx minus pi little r squared dx. And we're going to integrate. The limits are going to be in the x direction, so 0 to 2. The big radius is going to be y top on the line. So that's going to be x plus 2 squared dx. The little radius is going to be this, y top minus y bottom. So it's going to be x squared dx. And so that's good enough. That's the setup. If you want to check your answers, you can put it in your calculator and then do the other approach in calculator. So now I'm going to redo the problem. The same rotation on the x-axis, but I'm going to do parallel to the axis of rotation. So we're going to get shells. We're going to have to do two different sets of shells because what determines the height of the shells changes in the middle of it. So we're going to have to change at 2, and we're going to keep going up to 4. So the volume of a shell is 2 pi r h. It's going to be dy this time. So 2 pi, we're going to go 0 to 2 for the first set. The radius is going to be just y. It's going to be y top minus y bottom 0. We're just at whatever y we're at. The height of the shell is going to be x right minus x left. X left is 0. X right is the square root of y, positive square root of y. So that's the first one. And then we're going to go 2 to 4, and the radius is still y. The height of the shell, though, is going to be x right minus x left. So x right is still the square root of y. X left is this line, solve for x would be y minus 2. Put it in parentheses to make sure you distribute that subtraction unless you're going to do it in your work. Okay, now we're going to do it around the y-axis. So we have this shape here. We're going to revolve it around the y-axis. So it's going to look like that. So if we do, we'll just start with vertical slicing every time. Vertical slicing, we'll get shells because it's parallel to the axis of rotation. This time the shell approach pays off. And we get 2 pi. We're going from in the x direction, 0 to 2. The radius is whatever x we're at. The height is y top minus y bottom. Y top is x plus 2. Y bottom is x squared dx. That's your shells. Let's do another drawing. And we're going to go horizontal slices. This is going to give us discs and disc washers. So we're going to have to do two different sets. So we're going to have pi r squared. The first one is the radius is x right, which is the x value here on the, that's going to be the square root of y squared dy from 0 to 2. Then we're going to do washers from 2 to 4. And the outside washer is the same thing. It's square root of y squared dy minus pi 2 to 4. The little radius right here is the x coordinate on the line in terms of y, which would be y minus 2 squared dy. So that's the setup with horizontal slicing disc washers. Okay, now we're going to do the same thing, but we're going to rotate it around x equals 4. So we take our graph, and it goes right here. X equals 4 is right here, right? No, x equals 4 is a little more over here. So here's our drawing. And if we do vertical slicing, we're going to get shells because it's parallel to the axis rotation. So we're going to have 2 pi integral in the x direction, 0 to 2. The radius, always work off the original region. The radius is x right minus x left. And x right is 4, and x left is whatever x value we're at. So it's 4 minus x. The height is going to be y top minus y bottom in terms of x. So y top is x plus 2, y bottom is x squared dx. So that's your shells. We draw another quick picture. And so this time we're going to do horizontal slices, and they're going to be disk washers, and we're going to have to change our strategy right here. We're going to have to change our setup. So volume equals pi r squared. We're going to go 0 to 2 first, and the big radius is just x right minus x left. 4 minus 0 is just 4 the whole time. And then the little radius is inside, it's x right minus x left. It's 4 minus the x coordinate here, which is the square root of y, square dy, plus, then we're going to go 2 to 4. And up here, the big radius is 4 minus the x coordinate here in terms of y, which would be y minus 2. Minus the small disk in the middle, it's going to be 4 minus the square root of y squared dy. So that's that setup. Can't see it. That's that setup. This is good practice. It's tiring. Y equals 6. So the graph is going to be like that, and then we're going to spin around y equals 6. So if we do vertical slices, they're going to be dishwashers first, and they're going to be nice dishwashers. One set, volume equals pi. The big radius is down here. Y top is 6. Y bottom is square root of y, or sorry, x squared. It's the y value in terms of x, dx squared. 0 to 2, and then minus the whole, 0 to 2, 6 minus this, 6 minus this. It's going to be x plus 2. Now you got to subtract the whole thing, so make sure you put parentheses. So that's your vertical slices with disk washers. And then if we do horizontal slices, we're going to get shells. We're going to have two different sets of shells. So we're going to get 2 pi, and we're going to go 0 to 2, and the radius is y top minus y bottom, and it's going to be 6 minus y. The height is x right, square root of y, minus x left is 0, dy, plus 2 pi, 0 to 2. The next ones have the same radius, 6 minus y, not 0 to 2 to 4. So we're going to do this chunk up here. X right is the square root of y. X left is this x coordinate right here in terms of y, which would be y minus 2. So that's going to be your shell approach. Okay, I think you guys probably should be ready for dishwashers and shells after that. Arc length is going to be on part 1. So this is, you'll be allowed to use a graphing calculator for it. We could try and do this one by one. We could try and do it by hand, but okay. So remember the formula. It's very much like the formulas for length of polar curves and parametric curves. Has a square root, has something squared here, which happens to be 1 squared, and then dy dx squared. It has a derivative squared. So we do need to find the derivative. 3 halves x to the 1 half. And then we plug in the formula. We're going to go 0 to 1, 1 plus 3 halves x to the 1 half squared. And that's going to be 1 plus 9/4 x dx. And that's your setup. Now, if you want to integrate it, you would have to use substitution. It's doable, but it's a good amount of work that I'm not going to do here. Right? You'd keep going. You'd say, okay, well, it's going to be 4/9 square root of u to the 1 half, du, 4/9 u to the 3 halves, divided by the new exponent. 8/27, rewrite it back in terms of x from 0 to 1. Then you plug your values in, but we can do it on our calculator real quick. Math 9, square root 1 plus 9x divided by 4, close, comma x, comma 0, comma 1. And the answer is very quickly 1.439 or 1.440. Show your setup though. Next one. You have to use a graphing calculator. Y prime is cosine x. Length is 0 to 2 pi. Square root of 1 plus the derivative squared. And you can't integrate this. So that's your setup. And then we're going to do it on a graphing calculator. So math 9, square root 1 plus, parentheses, cosine x, close, squared, close, comma x, comma 0, comma 2 pi. $7.640. So show you setups. All right. So we got some arc length problems on here. We have some rate model problems. Rate models will be on part 1, graphing calculator allowed. So let's see. This is just fundamental theorem of calculus part 1. You have the derivative. So we could, if you integrate g prime, you're going to get g. We want 5, smallest, biggest, plug top limit first, bottom limit second. So we're looking for g5. So g5 is a fundamental theorem of calculus part 1. If you integrate a derivative, you get the original function. Plug in limits like normal. g5 equals g2 plus 2 to 5 of g prime x dx. g5 equals 2 is 3. G prime is x natural log of x, which we might be able to integrate with parts, but hey, if I allow you to use calculator, might as well go for it, right? So 3 plus math 9 x natural log of x, comma x, comma 2, comma 5. That's the answer, 16.481 or 16.482 if you want to round. So that's a little fundamental theorem of calculus part 1, which I said would be on part 1 and 2. So fundamental theorem of calculus part 1 is part 1 and part 2. Rate models, though, are part 1, graphing calculator. The tank contains 125 gallons of heating oil at time 0. So that's the amount at time 0. That's your initial condition. It says during the time interval 0 to 12, heating oil is pumped into. So that's positive rate. Heating oil is removed from. That's a negative rate. And so I'm going to just write my rate model real quick. My rate model would be AT plus the initial amount, which is 125, plus the incoming amount, which is HT 0 to T dt, minus the outgoing amount, which is RT dt 0 to T. So that's my rate model. A says how many gallons of heating oil are pumped into the tank from 0 to 12. They just want the into part. So they just want 0 to 12 of HT dt. You don't even have to write the function. If they named it that way, use the name. that's good enough in your setups. I think it might be helpful to type these in because I think we're going to have to do multiple calculations and they're pretty complicated. So 2 plus 10 divided by parentheses 1 plus natural log of x plus 1, close parentheses and natural log, close parentheses in the denominator, 12 sine x squared divided by 47. Make sure you're radian mode. So I just entered both those. I don't even know if I'm going to graph them. If I were to graph them, it says 0 to 12. I don't know. Why not? Let's just graph them. I would do zoom fit, which takes a little bit of extra time, but it makes a really nice graph for you. So let's see what this gives us. We might use it to find the intersections of these two curves. So the first one was the pumped into, the second was the removed from. So on the home screen, I could just say, all right, math 9, vars, y vars function y1, comma x, comma 0, comma 12. Take advantage of us typing those in. And we get our answer, 70.570 or 70.571. Put the units. What are these? Gallons of heating oil pumped into the tank during or from time t equals 0 to t equals 12 hours. It's a good, thorough answer. Okay, B says, is the level of heating oil in the tank rising or falling at time 6? Well, the overall rising or falling is like increasing, decreasing. The overall derivative is the incoming derivative, the incoming rate minus the outgoing rate. So I would just calculate what it is at 6, which would just be H6 minus R6. On my calculator, I can maybe use the table to help me do that. Or you could calculate them separately. So this is going to be 5.394536 minus 8.318728. And I can figure out what this is going to be. 5.394536 minus 8.318728. Negative 2.924 gallons per hour is our rate. So it's negative. So it's decreasing. The oil level is falling. So it says to give a reason for your answer. So we can say the level of oil, of heating oil in the tank, context is good, is falling at time t equals 6 hours since the rate is negative 2.924 gallons per hour. And it is negative. So, or you could do the individual rates and say that the rate being pumped in is less than the rate being removed, and therefore we're removing more than we're pumping in, and so the level must be falling. Okay, C says how many gallons of heating oil are in the tank at time 12? So we're going to use our rate model, which we should write for our setup. And we could calculate this all in one calculation on our calculator, taking advantage of, that's the setup, which we need to show, but we've put all these in here. So we could say 125 plus math 9 vars y vars function y1 comma x comma 0 comma 12 minus math 9 vars y vars function y2 comma x comma 0 comma 12. That should do it. 122.025 or 122.026 gallons of heating oil are in the tank at time t equals 12 hours. Sounds like an answer. D says, at what time is the volume of helium in the tank the least? So it looks like we're looking for least amount, which is an absolute min, which means we should do EVT. It says 0 to 12. 0 to 12 is going to be your endpoints. You need critical points, so that'd be the derivative, which is the incoming rate minus the outgoing rate, equal to 0 undefined. This is stuff you have to write down to get full credit. Now to solve this, we could say h equals r, and then I already have a graph of this, and it's going to be the intersection on that graph. So if I go to my graph, there's the two critical points. Second calc, intersect first curve, second curve, guess. Oh, I didn't do it. I think I messed up. Okay, maybe we got it right. Let's see. There it is. So one of them is 4.7900515. That's the time. That's what we want. Second, calculate, intersect, first curve, second curve. This is over here near 12. I'm going to guess 11. Quick guess. Okay, it is 11.31847. You need more decimal places than 3 because it's going to be in the middle of your work. So we have our critical points. So then we're going to make a table and put these in. And we're going to put them into our rate model, which is 125 plus the integral of h t dt from 0 to t minus the integral of rt dt 0 to t. We're going to do 0, 4.7900515, 11.31847, and 12. Now I think we've already calculated. If you plug 0 in and get 125, we already did 12 on part C, which was 122.025. So we just need to do these last ones. I'm going to actually recall my calculation from part C and use it just to cut and paste. So that's it right there. What I need to do is go in here and change the 12 to 4.79. So 4 point, and then I have to do second insert 7900515. So it pushes everything over here. And then this would be 4.7900515. And we get 149.407. And then I'm going to do it again and then change these to 11.31847. 11.31847. There's an extra decimal there. Waiting. 120.738. So we're looking for the least. This is the least right here. So let's write a nice answer. The volume of heating oil in the tank is least. I'm going to put the answer 120.738 gallons. I don't think I need to say heating oil because I already referenced it. Gallons at time t equals 11.318 hours. So that's the answer very thoroughly. By extreme value theorem, do not abbreviate it. Extreme value theorem by checking endpoints and critical points. Good answer, good justification, good units. Okay, I'm going to stop the video right now and make a separate video for the last 2 pages. And yeah, take a break.